I think those students, those who have joined, try to take maximum benefit of this training, and your doubts also you ask without hesitation. Shirgiri sir, you give some brief about the training first, introduce the speaker guest, and then you start with the thing.
Yes, madam. Yes, ma'am. So good morning, everybody. So today we have gathered here for the training program. So I welcome Sri Sachin Patil sir on behalf of our civil engineering department, Dr. D.Y. Patil Institute of Engineering, Pune. Now I will introduce our guest, Sri Sachin Patil sir. Now Sri Sachin Patil sir is working as a design and product development manager in Jain Irrigation System Limited. Now, sir has completed his master's degree in civil hydraulics engineering from Bharati Vidyapeeth College of Engineering, Pune. Now, sir has joined Jain Irrigation Company, this company, as a junior engineer in the year 2008. So, he has having vast industry experience in the field of irrigation, that is in the design and development of irrigation system related new products. So, he is developing new product, new catalogs. And so basically Sri Sachin sir is working in research and development department from last 14 years. Now sir is a pioneer in the silent revolution with modern irrigation systems and innovative technology in order to save precious water. Sir is also working on sustainable future while fulfilling its vision, leave this world better than you found it. So they are having vision, that is leave this world better than you found it. Now sir has 2 patents against his name and 12 research papers. So sir has published 2 patents with collaboration, and against his name he is having 2 patents and 12 research papers. So as he is working in the research department, so all papers are published in reputed journals, research journals. So sir has worked successfully on study, design and analysis of different geometry of inhibitor labyrinths used in the drip irrigation for clog-free performance. Now today sir will enlighten industry-based training on climate control in greenhouse. So greenhouse is a structure, so all of you may be knowing about the greenhouse. So it is a structure with walls and roofs made transparent material, such as glass, in which plants required regulated climatic conditions. So different techniques are then used to evaluate optimally degrees and comfort ratios of greenhouses. So such as air temperature, relative humidity and vapor pressure deficit. So sir is having a vast experience, and today he will give us the training and the different tools used for the training, different tools used to control the temperature. It is a major problem to control the temperature in greenhouse. So sir will enlighten on that. This is the introduction about sir. And so I request Sachin sir to start training session, as students are very eager to listen you sir.
Thank you, Anil sir. And thank you, Deshpande sir, Dr. Anil sir, Joshi ma'am, for giving me this opportunity. So, may I present my screen now?
Yes, sir. You can present your screen. You can present it.
Can you see my screen now?
Yes, sir.
Thank you. Now, before we start our presentation, I would like to request all the participants that this is not a presentation session. This is a discussion kind of session. Okay, I need all your participation. Okay. So let us start our session now. So the topic which I have received is climate control in greenhouse. Can anybody tell me what is greenhouse from student side? So Anil sir, can we discuss with students also, or it's muted?
Students are muted.
Okay.
I think they are
Okay.
muted. Okay.
Okay, let it be. So I will carry on. So basically, the greenhouses which I'm talking about is basically it is used for agriculture purpose only. So you all might have seen such structures near to Pune, near to Talegaon and all. Okay. So these structures were built by using different kinds of material like polythene, glass, polycarbonate sheets. There are different kinds of materials which are used to construct all these types of greenhouses. If you think about the construction of these polyhouses, the cost of the construction is too high. Just for an example, if you want to construct these greenhouses almost in a 100 square meter area, it costs you almost 10 to 12 lakhs. Okay. So when a grower or when a user construct this type of greenhouse, his expectations were too high. You know why? Basically, greenhouse is constructed. Yes. Okay. So greenhouse is constructed to grow their crop in controlled environment. So this is like a small house for a greenhouse, for a small house for the crops. Okay, where we can maintain temperature and humidity. Temperature and humidity, these are the important terms for the crops to grow. So we will see all these things ahead. So you all might have studied this greenhouse effect. What is greenhouse effect? So I think nobody can talk, so I will just explain this. So you all might have studied this. So solar radiation reaches Earth atmosphere. Some amount of light will reach to the Earth, and some amount of light will be reflected back, okay, in the atmosphere. Okay. So this is first step, and in the second step, what will happen? So the rest of sun energy is absorbed by the land and ocean, heating the Earth. Okay, this is the second step. So in the third step, so heat radiates from Earth towards the space. Some amount of heat goes up, and some amount of heat is trapped in the atmosphere. Okay, so I'm telling you this is just a theory which you have studied, and nothing different than that. So some amount of heat is generated by our manual interventions like industrial waste, like vehicles and different kinds of vehicles. So because of that, we are going to generate some heat. Okay, so that heat is that is called as a greenhouse effect. Okay, so basically the greenhouse which we are talking about is exactly not similar, but it has some close effects like a greenhouse effect. So this is just a two-dimensional drawing for the greenhouse. You can see this greenhouse drawing. What this greenhouse is doing, some amount of light is allowing to go inside, and some amount of light is reflected, and the light which is going in, it can reach to the crop, and some amount of light which is reaching the ground, it can generate some heat, and it is stored in the greenhouse itself. Okay, and this is used for the crops. Okay, and there were some different kinds of benefits also which we are getting from the greenhouse. Is like a rain, storms, some bird, and some insect. These are some hazardous effects which were going to happen on the crop. So we are avoiding those things also by constructing the greenhouses. Okay, so basically this we have studied now. So we are getting a protection against wind, sand, rain, and all. Okay. We can give some crop support also. Okay. We will see all these factors ahead. So there are some different kinds of benefits which we are getting by constructing the greenhouse. Okay. So basically, the demand of customer is good quality, good shape, taste, and firmness, color, non-sensational availability. And these are some requirements of the customers. Okay, so which we are going to achieve by using the greenhouse. Okay, so when you construct the greenhouse, there are three important terms which you need to work. So first thing is light, second is a temperature, and third one is a humidity. Okay. Hello. Sorry. So when we are talking about the greenhouse, the three important factors which we are going to control in greenhouse is light, temperature, and humidity. Okay. So basically, when you see the light concentration which is required for the crops is almost around 40 to 700 nanometers. Okay. But if you see the average summer Indian summer day, we can generate up to 2000 micro instance per square meter. Okay, so this is huge amount of light which we are going to achieve in a summer days. So which is really not necessary for the crops. So what we need to do in a greenhouse, we need to control the amount of light which is going in the greenhouse. So how do we achieve all these things? So if you have an excess light in summer days, so we have some different kinds of shade nets, different kinds of shades available in a greenhouse. So you can open it. So once the light is too much, then you can open it. Once the light is low, then you can take it out. So there are two different kinds of problem. One is a excess light and one is a low light. Okay. At some particular cases, you may get some issues like a low lights also. In that case, sometimes you need to open the roof, or sometimes you need to clean the roof. Why cleaning? Because sometimes there is a dust problem on the top of the greenhouse. So you need to clean that dust. Okay. So if you are in a low light regions, then you need to use some power lamps also for getting additional extra lights. Okay. So these are some of the things which we need to look as far as the light problem is concerned. So this is a shading net, and this is operated with the help of fully automatic pump. Okay. So if you look at the specifications of the shade net, this is a thermal net. So this is made of 50% aluminate thermal net. So this is basically used for the control of light. If you have excess light, then you just need to pull out this thermal net. So it will not allow excess light to go near to the crops. Okay. So this is something about the adjustment of the light. So if you have some dust problem or light problem, so in that case, what you need to do, you need to put the sprinklers on the shade house. Okay, just to wash out all the dust. Okay, so these are some different kinds of sprinklers just to clean for the cleaning of greenhouse from outside. So if you have a low light region, still you have a low light region, then you can use a power lamps. Okay, these are the power lamps. So which by using this you can increase the light intensity as well as the heat in the greenhouse also. Okay, so these are some different kinds of lights which we are going to use. So basically, so this is about the light. Now we will discuss something about the cooling effect. So why greenhouses need the cooling effect? Because see, there were some crops which need some specific temperature range or humidity range in which they can grow better. Okay, so this is the main difference between open agriculture and climate control agriculture. Okay, So just for an example, if you take an example of sugarcane can grow better in the temperature of 22 to 26 degrees Celsius. Okay, if the temperature is going beyond 26 degrees Celsius, it will not die, but it stops its growth. Okay, this is what the study is showing us. So in the same kind, there are some different kinds of delicate crops like flowers, like vegetables, so which they need some climate control. Okay, where they can grow better, they can give better yield with good qualities. Okay, so these are some of the things which we can achieve by giving the cooling system. Okay, so there are different kinds of cooling system. One is a wet pad and fan pad cooling system. We're calling it as a fan pad cooling system. This is a pad, wet pads, and this is the exhaust fans. Okay, so you can achieve some cooling system by using this type of system. You can use the fogging systems, okay, to achieve some cooling effect. Okay, you can use the air conditions, which is little bit costliest option for the greenhouses. So, and the fourth option is the air circulation fans. You can use some exhaust fans. So by using that, you can just take out all the heat which is trapped in a greenhouse. Okay, these are some different kinds of cooling system which we have. Okay, so just for an example, I'm just showing you the different kinds of pads. Okay, this is a pad on which we are spraying the water. Okay, so whatever the air is at outside, there is a fan on the other side. This fan is on the other side. So this is an exhaust fan. If you can imagine a small greenhouse over here. So this is an exhaust fan. This is a pad, cooling pad. So when you start the fans, so amount of heat trapped in the greenhouse, it is exhausted out, and the air which is outside and which is cooled in a pad, it goes in the greenhouse. This is just a simple terminology how we can control, we can get the cooled air in a greenhouse. Okay, this is a pad system. Okay, again, we have some different types of calculations for cooling the pads. Okay, so earlier there were some conventional method to pour some water on the pad. So, but nowadays we have some designed some specialized spraying systems, which we can get some uniform spraying of water as well as getting the uniform temperature of air. Okay, by using these spray heads. Okay, so these are some exhaust fans. They are taking out all the heat from the greenhouse. So now the third option is a fogging system. So you can use some fogging system. Fogging system is nothing but you are spraying some water in a greenhouse. So as there is a heat trapped in a greenhouse, by which the sprayed water can be if you spray the water in heated environment, what it does, it will absorb the heat and try to cool the temperature in the greenhouse. Okay, this is a simple concept, and even the most of the greenhouses, they use fan pad cooling system as well as a fogging system. Okay, so now we are trying to study some temperature and humidity control in a greenhouse. Okay, so you all might be knowing the definition of latent heat. Actually, what is latent heat? Latent heat is nothing but 1 calorie is amount of heat necessary to raise the temperature of 1 centimeter cube of water by 1 degree Celsius. So I hope I'm correct. So you are very close to the theory, so you might be knowing the better definition. I hope I'm correct. So basically, what I'm trying to say, just for an example, you just take an example of ice. So if you want to convert ice into water, how much amount of water, how much amount of calories you need? It's almost 80 calories. And when you want to convert the water to vapor, how much amount of calories you need? Almost around 590 calories. Okay. So this is the way we are going to achieve the cooling effect. This is in simple terminology, fogging system is nothing but an evaporative cooling system. Okay, we are spraying some small droplet sized jets or foggers. So that water is sprayed in the greenhouse, and the heat trapped in the greenhouse, which absorb that water and give the cooling effect. So in simple terminology. So this is just an example how the fogger works. So when we are thinking about the temperature and humidity control in greenhouse, so there were some different kinds of factors. Okay, so which we need to understand before we construct the greenhouse, like a external temperature, external humidity. There are some different factors also, so that we need to understand before we construct the greenhouse. So now the engineering terms comes into the picture. So when an engineer comes to design the greenhouse, so the important term which he need to do is how much water do we need to control the greenhouse. So this is a small psychrometric chart. Actually, there are some different kinds of calculations. So we, by using those calculations, by using those algorithms, we have constructed this psychrometric chart in one of the university in Israel. It's in Tel Aviv. So they gave this chart. So where so when we construct the greenhouse, the temperature which we need to achieve is almost around 28 degrees Celsius, and the humidity is almost around 80%. So if you take this combination, 28 degrees Celsius and 80% humidity, this is just generalized term. Okay, so this is a minimum criteria. This is a minimum requirement for the greenhouse. Okay, that's why this psychrometric chart is prepared for 28 degrees Celsius temperature and 80% humidity. Okay, just as I said earlier, so when you want to calculate the water requirement for controlling the temperature in greenhouse, you need to know the outside temperature. This is an outside temperature. Okay, and there is one more term, that is an outside humidity. Okay, let us say an example. So if you have outside temperature is almost 40 degrees Celsius and outside humidity is almost around 20%, just for an example. So how much amount of water you need to to cool the greenhouse? You just take this graph on the top. This is a 20% humidity, and just go horizontally. How much amount of water you need? It's a 1500 grams per square meter per hour. How much amount you want? It's a 1500 grams of water is necessary per square meter per hour. Okay, so this is again multiplied with respect to the area. Means sometimes your area is 100 square meters, sometimes your area is 4000 square meters. So this is totally again multiplied with the area. Okay, this is about the water requirement which we can calculate in the greenhouse. So the second thing, so when you calculate the amount of water required to cool your greenhouse, so the second term comes in mind. So how do we need to spread that water in the greenhouse? So for that we have some foggers. I hope you can see this is a fogger, and these are some fogging systems. These are the foggers. Okay, these are the small droplets. So we are throwing the water in greenhouse in small droplet size. Okay, you can see. I think you can feel you can see the fine droplets over here. So we do have some different kinds of products for fogging, for making the fog. So these are some giant foggers. Again. So what I need to show you, this is the flow rate which you want. Okay. So if you operate this fogger at 4 bar pressure, it gives you 7 LPH. Blue colored. Okay. We have violet colored also. It's a 5.3 LPH. So why we need this different flow rate nozzles? Because if you are working in a high tempered area, so you need to reduce down the spacing between the foggers. Okay, so how to place the spacing, that also we are going to see. Okay, so this is again a different kind of fogger which we can use for in a greenhouse. So the next question comes in mind is, how will the droplet size affect on the performance of a cooling system? So you all might be knowing. So if you spray a water in a closed room continuously, what will happen? All the water can try to settle down on the ground. Okay, so this is an example. Okay, so now we will see this graph. See, if you have a greenhouse where you have achieved almost 80% humidity or 50% humidity or 30% humidity. So how much amount of height is required to evaporate that drop? Okay, I will just take an example. See, if you have a 100 micron drop, can you see this 100 micron? I hope you can see this 100 micron. If you have this 100 micron drop, and you have a 30% humidity present in a greenhouse, so how much height you need to evaporate that drop? For 30% humidity, how much height you need? Almost 1.2 or 1.5 meter. Okay, almost 1.2 meter height is necessary. Okay, if the humidity is little bit higher, then again, how much amount of height is necessary to evaporate that drop? Is almost 2.1, 2.5 meter height. Okay, if the relative humidity is again much higher in a greenhouse, almost 80%, so again it needs 5 meters of height. Okay, so why I am telling you, we will see a small video also for that, why it is necessary. Because see, the main requirement of greenhouse is, when you spray the water in greenhouse, it shall not reach to the crop. This is the first important criteria. So when you construct the greenhouse, because see, if you are growing flowers or vegetables, so if the water which you are using for the cooling and humidification, if that water reaches the crop, what will happen? There may be some spots on a crop, so which is not a good quality, so which affect the price and all. So that's why the prime importance is, so the drop which you are going to spray, it shall not reach the crop. So this is an important thing. So that's why this chart comes in a picture. Okay, so now, as I said, if you operate the foggers in a greenhouse, some amount of water will definitely reach the ground. Okay, so then how to minimize the amount of water that reaches the ground? How to minimize? So actually, these are some interactive kind of things. If the students can come and they can talk, then this will be an effective session. So let it be. I will just continue. So the ideal solution is a pulse operation. So some of you might be knowing the pulse operation. Pulse operation is nothing but on-off operation. So we operate foggers for few seconds, then again we stop the operation for few seconds, and then again we operate for few seconds, and then we again stop the operations. Okay, why it is necessary? That we will see. See, these are some foggers which we have. So this is an insolation image. So this is something about the pulse operation, how it is calculated. So what I said, so what we will do, we will just take an example. Okay, so just to get an idea. Okay, so for example, your target is to achieve 28 degrees Celsius in a greenhouse, and how much amount you want? It's a humidity you want, it's a 80%. And now, as I said, the outside temperature and outside humidity is also important factor. So just for an example, you assume that in Pune, you have almost 40 degrees Celsius outside, temperature, and relative humidity is almost around 20%. Okay, so we will just see the graph. What is the outside temperature? How much it is? It's a 14 degrees Celsius, and here is a 20% humidity line. It is coming down. So if you calculate this with the horizontal line, so how much amount of water is necessary to get your achieved or required temperature and humidity range is almost 1,500 grams per square meter per hour. So how much amount we want? 1,500 grams per square meter per hour. Okay. If you convert this in liters, it's a 1.5 liters per hour per square meter. Okay, this is square meter. Okay. So basically in greenhouses, we in Maharashtra region, we try to tell the customer that you can put the foggers almost on 3 meter by 3 meter area. So lateral to lateral is 3 meter, and the fogger to fogger spacing is a 3 meter area, 3 by 3 meter. Okay. So we can say one fogger, 28 LPH. How much amount it can cover? 3 meter by 3 meter. Okay. So if you want to calculate the application rate or precipitation rate, so you just have to divide this LPH, 28 LPH divided by area. So how much amount of water you are going to spray by using this fogger? 3.1 liters of water per hour per square. I hope you are understanding this. You are trying to understand this example. So this is an important example. Okay. So what we did here. So we just have calculated the amount of water required to cool my greenhouse. Okay. So this is the first step, and in second step, so when a company gives an instruction to the grower, you can install the foggers at a 3 meter by 3 meter spacing. Okay. Then how much area it can cover? 3 by 3. It means 9 square meter area. Okay. This is the second step. In the third step, what we are going to calculate is a fogger flow rate. So how much amount of water that one fogger can fall? Okay, one fogger can create. It's a 28 liters per hour. Okay. And the fourth step is calculating the precipitation rate. So you all might be knowing, we are calculating precipitation rate. It's like a application rate. Application rate is nothing but you can calculate the rain also. So how we are calculating the rain? How we are calculating the rain? Amount of water falling in that area divided by area. Okay, that thing only we are calculating over here. This is the amount of water, and this is the area. So how much amount of water we are putting in a greenhouse per square meter? It's a 3.1 liters per hour per square meter. Okay, this is what the achieved result. But how much amount we want? This is a 1.5. How much more? How much we want? It's almost 1.5 liters per hour per square meter. But how much we are going to achieve is a 3.1 liters per hour per square. Okay. So as I said earlier, so you can see the pulse operations over here. So why we are going to do like this? Because the amount of water which we are going to spray, it shall not reach the ground. It will get evaporated in the environment. Okay, before it reaches to the ground. Okay, this is again a 28 liter fogger. Okay, so as I have calculated, amount of water required is 1.5 liters, but amount which we are going to spray is supposed to be 3.1 liters. How we can reduce down to 1.5? We can make some pulse operations. We can make a pulse of 3 seconds on, 3 seconds off. Okay, it means that in 1 hour we are going to operate only 30 minutes of fogger. It means we are going to spray only 1.5 liters. So that's why the pulse duration is 3 seconds on and 3 seconds off. Okay. So this is what some layout of fogging system. Okay. So where we are going to install, how we are going to install the foggers. These are the foggers. Okay. This is the 3 meter by 3 meter, and this is again a 3 meter by 3 meter. In high tempered area like Rajasthan, Gujarat, high tempered area, we are trying to tell them that instead of 3 meter by 3 meter, you just go with 3 meter by 2 meter spacing. Okay. Again, there were some different calculations. Okay. So which we are calculating before constructing the greenhouses. Okay. So this is how the greenhouse, how the fogging is going to create in a greenhouse. Okay. So when you operate the system in a pulse operation, so the amount of water reaches to the crop is minimum. Okay. Now this crop is not a flower or floriculture crop, so that's why this is going to happen. We are so we as a Jain irrigation, we achieved some different kinds of results also by using this fogging system. We have tried some pesticide spraying system also by using this fogger. So, and we achieved some good results also. Okay. So I think we have some example for the photographs. So maybe in later slides. So we have one more hydrogenated fogger. This is an hydrogenated fogger where you can achieve the droplet size up to 5 to 10 micron also. In conventional foggers, this is a conventional fogging system. In this fogger, the droplet size is almost around 100 micron. It is too big. Okay, so this is a new kind of fogger. It's a hydropneumatic fogger. So by using this hydropneumatic fogger, you can achieve the droplet size of almost around 5 to 10 microns. It's too small. Okay. So where you can say a guaranteed result that the water will not reach the crop. So this is a structure of the greenhouse. This is a structure of the fogger. This is a schematic layout how we are going to install the fogger. You can see the fogging over here. So if you put your hands in the stream, then also you will not get the wet film on your hands. So there are some different kinds of applications where we can use this type of fog, humidification, phytosanitary treatment, dust suppression. There are some different kinds of applications. I would like to tell you something about how it works. So you can see a cut section over here. From this side, water is going in, and from this side, air is coming. So air is coming by this way, and water is coming from here, from the center. So at this point, water and air get mixed, and it is thrown outside. Okay, in fine droplet. So this is like a hydropneumatic fogger. You can say this is just an atomizer also. So for a civil engineer and mechanical engineer, so you can understand how atomizer works. So this is just nothing but a small atomizer. Okay. So these are some installation kind of things. Okay. So some different kinds of applications for foggers. Technical chart. Okay. One more important thing which I would like to tell you. So as we are telling you that when foggers were operated in a pulse operation, I mean to say 3 seconds on and 3 seconds off. So is it really possible by using manual system? So one can sit there 3 seconds on, 3 seconds off. It's not possible by manual operation. So that's why we need some automatic controllers. So giant irrigation is having some different kinds of controllers, like a fully automatic controllers. So where these controllers can be operated with respect to getting the temperature and humidity in the greenhouse, like fully automatic. So okay. So if your greenhouse achieve 80 degrees, 80% humidity and 28% temperature, 28 degrees Celsius temperature, so your controller stops operation. When again it goes above or below, then again it starts operation. So this is a fully automatic system. So these are some different kinds of controllers which we have. This is and again high range controller. Then again for the low cost customers, so we have again a time based system. So these are some different kinds of controllers which we have in our catalog. So as I said earlier, so we did some study on a pesticide spraying by using the foggers. So we achieved some very good results in cucumbers with different kinds of crops. So this is just a success story for that. So at that region, the fogger discharge is almost 30 liters per hour. Two-way fogger, 6.4 LPH by 2, 13 LPH, and the fogger to fogger spacing is 1.5 by 2.5. Basically, this trial was done in Israel. So this is the all data is related to Israel. Okay. So we are operating this fogger at 5 bar pressure. So these are some system details. So how we constructed. Basically, when we did the trial research, so we did both trials. Okay, like a hand sprayed trial, and then again fully automatic means fogger system sprayed trial. So we got very good trial, very good results by using the fogging foggers. Okay, so these are some of the results how we achieved fogging system or pesticide spraying system by using the foggers. Okay, so if you have any questions, then you can ask. Thank you.
Yes, Sachin sir.
Yes.
Very nice, informative session. And in spite of busy schedule, you have given this training to our BE civil engineering student, that is how to control the temperature in greenhouse. So I am very much thankful to you. Can you show a few images of greenhouse? Is it possible?
Yes. I can show you different images for the greenhouses.
Yes. Because students will come to know what is greenhouse and what are the different structures.
Okay. I will just open the presentation. Okay. I'm just opening a greenhouse. Okay, the presentation which I have.
Yes, sir. Yes. Okay.
Can you see my screen? Anil sir, can you see my screen?
No, it is not visible yet. Your co-host, you.
Okay. Oh, sorry. So can you see the screen now?
Yes, sir. Yes, sir.
So this is just this is our greenhouse catalog. So I'll just try to show you different kinds of greenhouses, which we were providing the solution, as a solution to the customers. So see, this is a walk-in tunnels, a small tunnels where you can go, you can grow some different kinds of walk-in tunnels. This is just like if you have different kinds of crops, and if you want to grow these crops at in small spaces, so we suggest customers that you just prepare this walk-in tunnels. This is just a walk-in tunnels. So if you have different kinds of walk-in tunnels, you either you can grow same crop or you can grow different kinds of crops also. So this is just a walk-in tunnels and naturally ventilated greenhouse. This is a naturally ventilated greenhouse. So you can see this is an opening and there is one more opening on the top. So you just what you need to do is this is a low-cost greenhouse where you just need to open the shade on the top and bottom. Simple, low-cost, naturally ventilated greenhouse. So again, this is a poly house. You can see this is a poly house. Okay, with a fan pad cooling system. This is a fan pad cooling system, poly house. Basically, see, poly house is constructed either by using polythene or polycarbonate sheet or glass also. Okay, so these are some different kinds of greenhouses. Yes, this is constructed with a glass. This is, I think, this is constructed by using a polycarbonate sheet. This is by using polythene, and this is a general. Okay, so these are some different kinds of poly houses which. Yes, Anil sir.
Okay, sir. Okay, sir. So I am very much thankful to Sachin sir. In spite of busy schedule, sir has given training to our BE civil engineering student. I am also thankful to our HOD ma'am for giving us permission to arrange this training program. And lastly, I am also thankful to all faculty members and all the students for patiently attending this session. So I declare that this session is over. Thank you, Sachin sir.
Thank you, sir.
Okay, okay.